In this lecture, we are going to discuss firewalls, an important concept in cybersecurity. So firewalls are the first line of defense against attacks. Whenever there is an attack on your corporate network, firewall will be the first thing to intercept that attack. So designing good rules for the firewalls and selecting appropriate firewalls is very important to ensure a strong cybersecurity posture. Now firewalls can be composed of software, hardware, or both. We can have firewalls which are just built on software. They're cheaper, more flexible. Then we have firewalls which are built on hardware. So they have their own dedicated hardware. So for example, for software-based firewall, you could perhaps install the software on your gateway node. But for hardware-based firewalls, they have their own dedicated hardware, and both have pros and cons. So for instance, hardware-based firewalls have a big advantage in the sense that they are very quick and fast because they have dedicated hardware. And if you have a big corporate network with lots of traffic outgoing and incoming, then it makes sense to invest into a hardware-based firewall because it is very fast, more efficient. Every firewall is basically governed by rules, and these rules decide whether particular traffic would be allowed or blocked. We have different types of firewalls. A major categorization could be host-based or network-based firewalls. So host-based firewalls are more focused towards providing security for the end systems, whereas network-based firewalls are more general and they cover the whole network. Some of the popular flavors of firewalls are Palo Alto, Juniper, Cisco, and there are many others. Let's see how firewalls operate. So basically, every firewall has a set of rules called access control list, which specifies which type of traffic and which type of IP addresses are allowed and which of those should be blocked. So in this example, we have an outside source with the source IP address of 202.240.2.1, which wants to send some data to our corporate network. But if you notice the firewall, it says that IP address 202.240.2.1 should be blocked. So the decision is to deny traffic which is coming from this IP address. So when this packet is sent, it will be blocked by the firewall and it would not be able to enter the corporate network. In contrast, in this example, the firewall states that IP address 202.240.2.1 should be allowed to enter the corporate network. So the default decision is to allow it. So this time when the packet passes through the firewall, it would be allowed. So that's why it is often said that a firewall is only as good as the rules that it specifies. So the strength of your access control list specifies the strength of your firewall. Now let's have a look at firewall operations. The list of firewall rules is called an access control list. Rules can allow or block traffic based on several factors, such as source IP address. So basically, you should make sure that known malicious IP addresses should be blocked. There are lists available on the internet which lists known malicious IP addresses, and you should add those. A firewall can also block based on the destination IP address. So for example, you need to make sure that nobody from the outside should be able to access your internal database servers, for example, right? Or you have sensitive servers or sensitive PCs, then you can add the list of those IP addresses to your access control list in the firewall. And if there is any request which is destined towards these sensitive servers, then it can be blocked by the firewall. You can also block based on the source port, or you could block based on the destination port. So for example, as we discussed previously as well, HTTP, which operates on port 80, the web server, it is vulnerable to attacks because it transmits all of the data in plain text. It's a very bad idea. So you may add a rule that if there is a traffic destined to port 80, block it. So even if you have HTTP server running by mistake, shouldn't run in the first place, you should have HTTPS running on port 443. But even then, you still can block the traffic. Similarly, you can add telnet port 23. Telnet is just like SSH for remote shells, but the problem is that it also transmits data in plain text. So that's again a bad idea. So you could, block based on specific destination ports as well. You can also block vulnerable protocols. So for example, the ping utility, which uses the ICMP protocol, it's widely used throughout the world to launch denial of service attacks. Because it's really simple. You just write a script which generates thousands and thousands of packets repeatedly and sends it to a particular server. And imagine if you have a couple of these systems which are sending traffic, then you can overwhelm the network or the server. So a lot of the firewalls by default, they block ICMP traffic for this specific reason. Let's compare stateless and stateful firewalls, another important categorization of firewalls. Consider this scenario. You're inside the corporate network and this is your IP address. And you want to send some traffic to this public server with this IP address. So naturally you create a packet, you put your own IP address and you put the IP address of the destination server. And now if you see the access control list of the firewall, it says that if there is any IP for outbound connections, if there is any traffic coming from any IP address, any internal IP address, and going to this IP address, you should allow it. So in this case, the traffic would be allowed. The problem, however, is that there is no corresponding inbound rule. So the problem comes when this server tries to send a response packet with the source IP of its own, 188.122.13.2, and with the destination 202.240.2.1. This unfortunately would be blocked at the firewall, because there is no corresponding inbound rule. Now this is the problem with stateless firewalls. You need to separately configure both outbound and inbound connections. So this problem is solved by stateful firewalls, which work more intelligently. So considering the same scenario, this time when your packet passes the firewall, it intelligently adds a corresponding inbound rule. It knows that this connection was initiated by a trusted system from inside the corporate network. So it adds a rule that when I see traffic coming from this IP address 188.122.13.2 and it is going to this destination, and this is an added security feature, this is for this particular destination, not to any internal system. So allow it. So this time when the response packet comes, it will be allowed by the firewall to pass. Now stateful firewalls intelligently add corresponding rules and they make the job very easy of managing the security of your network. Let's discuss another important concept, which is next generation firewalls. So next generation firewalls operate at the application layer, also layer 7 of the OSI protocol stack or layer 5 of the TCP IP protocol stack. They are also called deep packet inspection firewalls because they inspect the contents of the packet, not just the headers as we discussed previously. So normal firewalls, previously they just inspected, for example, the source IP, destination IP, port number, stuff like that, header information. But next generation firewalls, they delve deep inside the packet and they perform a deep packet inspection. They're also called application level gateway firewalls because they also understand applications and they can detect patterns. They can identify it's a Skype traffic or let's say it's a video traffic. So the key point to understand is that they inspect applications, not just the network headers. So they can detect if the traffic is from YouTube, torrent, Skype, and based on that, they can intelligently adopt rules. Another major advantage is that since they know the app, so they have, based on the traffic pattern and the headers, they can detect which app is being used. So they can then use specific attack signatures. For example, let's say Skype has certain vulnerabilities. So once based on the headers and the packet data, once the next generation firewall has detected that it's a Skype connection, then it can apply specific attack signatures which are targeted towards Skype attacks. They can also intelligently detect patterns and payloads and block domain names, malware, spam. So next generation firewalls provide a lot of firepower. They can even block or allow specific applications. So for example, as a network administrator, you may specify that block Skype. Now, the next generation firewall is going to check the contents of packets, the payloads, and it's going to detect that this is Skype traffic. And based on that, it can block it. But sometimes you need to block parts of an application. For example, you may want to allow Skype because it's a good tool for video conferencing and people use it in your corporate network. But you want to disallow uploading and downloading of files, because somebody can send malware through Skype, and if somebody downloads that and installs that, it can infect your whole network. So you can even allow or block specific parts of applications using next generation firewalls. But perhaps the most important capability of the next generation firewall is that it allows application of specific signatures, and this provides for better intrusion prevention. Now this concludes our lecture on firewalls. I'll see you in the next lecture.